Below is an extensively expanded, rewritten version of the passage. It maintains the original meanings and core details, but adds significant background, descriptions, and explanations to exceed 10,000 characters. Enjoy this deep dive into some of the cosmos' most bizarre and terrifying planets, along with a few ominous details about our own solar system, terrifying worlds, and cosmic nightmares. The universe is vast and teeming with phenomena we can barely comprehend. Astronomers, armed with sophisticated telescopes and other advanced technologies, continue to discover distant worlds that defy our expectations, and sometimes our deepest fears. These planets often exhibit nightmarish conditions: skies filled with molten glass rain, blazing hot surfaces that can vaporize rock, or swirling storms capable of producing near-constant lightning. In our own solar system, we have places like Venus, dubbed Earth's evil twin, where acid rains down from toxic clouds, and the pressure is enough to crush many Earth-made machines. Yet once we peer beyond the Sun's immediate domain, we find exoplanets that make even Venus seem tame. Below is a tour of some of the most terrifying worlds known to humanity. Prepare to journey into the cosmic unknown, where the bizarre and the horrifying merge, to create phenomena straight out of a sci-fi horror story. The darkness of Trieste 2b distance and basics, located about 702 light-years from Earth. Trieste 2b orbits a star in the constellation Draco. This exoplanet is a gas giant roughly the size of Jupiter, one of the largest planets in our solar system. Why it's so frightening black as coal. While gas giants often reflect a portion of their star's light, Trieste 2b reflects less than 1% of the starlight hitting it. This makes the planet darker than any known black acrylic paint on Earth, effectively rendering it a cosmic black hole for visible light. Enigmatic composition. Scientists still do not fully understand which gases or particulates cause such intense light absorption. Some theories point to high concentrations of sodium or gaseous titanium oxide in the upper atmosphere, both of which might trap or absorb light. But so far, no definitive conclusion has been reached. A subtle red glow. Despite being one of the darkest planets observed, Trieste 2b isn't completely black. The star it orbits heats its atmosphere to around 980 degrees, 1,800 degrees, hot enough to make the planet glow faintly in a dim, ember-like red. Imagine stepping onto a massive world with the approximate diameter of Jupiter, where your surroundings are cloaked in near-total darkness, yet occasionally the surface or swirling atmospheric layers glimmer with a ruddy glow, like cooling coals in a dying fire. Astrophysical curiosities. Orbital proximity, TRES. 2b is only about 4.8 million kilometers, 3 million miles, from its star. This proximity means it is tidally locked, likely showing the same face to its star at all times, a phenomenon that can create extreme temperature gradients. Scientific importance. The planet's albedo, reflectivity, is significantly lower than almost any previously studied exoplanet or celestial body. Learning why Trieste 2b is so dark helps astronomers refine models for atmospheric composition and heat distribution, potentially offering clues about similar planets in other star systems. The lightning world of HAT P11b overview distance, approximately 122 light-years away. Size, roughly Neptune-sized, placing it among the smaller category of gas giants discovered around other stars. Fear factor lightning storm. Overload, Earth's thunderstorms, though sometimes intense, pale in comparison to what occurs on HAT P11b. Radio telescopes on Earth picked up surprisingly powerful radio signals from this planet, which scientists believe are generated by colossal, persistent lightning storms. Extreme energy output. If we try to compare it to Earth, we find that a global lightning storm covering our entire planet wouldn't come close to producing a signal of equivalent strength. Researchers estimate you would need over 3 million lightning flashes per square kilometer every hour on Earth just to match what is apparently happening on Hathi P11b. Such a scenario boggles the mind. A planet perpetually assaulted by continent-sized lightning storms, with the skies aglow from unceasing electrical discharges. Why it matters to astronomers. Electromagnetic profiles. Detecting radio waves from exoplanets is generally challenging, but when successful, it can reveal properties of an exoplanet's magnetic field, atmospheric composition, and weather patterns. Atmospheric dynamics. Continuous, planet-wide lightning storms imply a highly dynamic atmosphere, something that can provide insights into the planet's temperature, chemical makeup, and climate cycles. The ultimate Frankenstein creation, WASP-12b, destructive fate, lifetime. WASP-12b is on track to be destroyed by its parent star in roughly 10 million years, an astronomical blink of an eye, given that typical star lifetimes can be billions of years. Orbit. Hugging its star at such close range that its atmosphere is being stripped away, the planet sits precariously near destruction. Eerie characteristics, tidal locking and egg shape. WASP-12b orbits so near that it experiences intense tidal forces. These gravitational tugs elongate the planet into an ovoid shape rather than a sphere. Surface temperature and color, clocking in at around 2010 degrees, 4010 degrees. WASP-12b's surface is hotter than many stars' outer edges. Observations suggest it is as black as newly laid asphalt, possibly because of complex carbon molecules or metals in its atmosphere that readily absorb visible light. Atmospheric bleeding. The star's gravity tugs on WASP-12b so powerfully that the planet's outer gases, full of hydrogen and helium, stream away into space. It's like watching a cosmic vampire star slowly devour its giant planetary companion. GJ-436b, a world of burning ice. Location and temperature distance. About 30 light-years from Earth. Stellar separation. Orbits at just 6.4 million kilometers from its star, much nearer than Mercury's 57.9 million kilometers to our Sun. Heat level, estimated to be around 438 degrees, 820 degrees, ordinarily hot enough to vaporize water on Earth. The strange Ice 7 burning ice. Phenomenon. Despite the searing surface conditions, water on GJ-436b remains locked in a solid form called Ice 7. Under extreme pressure, particularly from the planet's gravity, water molecules compress into a crystalline structure that remains solid at high temperatures, an exotic phenomenon that doesn't exist naturally on Earth's surface. Gravity's role. Deep within the planet, gravitational forces compress the interior, so any water present is forced into a solid lattice. Meanwhile, if you could stand there, ignoring the destructive heat, you might witness the surreal sight of ice that never melts under normal conditions. 55. Cancri E, the Diamond Planet, aka Janssen. Why it gleams, carbon-rich atmosphere. The planet, about 40 light-years away, appears to have an atmosphere high in carbon. Under astronomical pressures, carbon can be compressed into diamond. Estimates suggest as much as 1/3 of 55 Cancri E's mass might be diamond. Temperature extremes. With surface heat around 2204 degrees, 4000 degrees, plus internal pressure, the conditions on 55 Cancri, Facilitate exotic mineral formations impossible on Earth. Supercritical water and toxic gases. State of water. Temperatures and pressures so high mean water can't maintain a standard liquid or gas state. Instead, it becomes supercritical, existing in a borderline condition that can exhibit properties of both gas and liquid simultaneously. Possible hydrogen cyanide. Observations from the Hubble Space Telescope suggest that hydrogen cyanide or other poisonous molecules might ooze from below the surface. Combined with scorching heat, these toxic emissions make the planet utterly inhospitable. Monetary valuation. A theoretical $26.99 million. Although purely speculative, someone once tried to put a price tag on this diamond-studded world. Obviously, buying a planet is beyond science fiction, yet the notion underscores the planet's incredible carbon wealth and the extreme conditions that forged it. HD 82606b, the Extreme Seasons Planet Eccentric Orbit Binary. Star System HD 80606b orbits one star in a system of two. Its path is so elongated that sometimes it's 127 million kilometers from the star, similar to the distance of Venus from the Sun, and other times just 4.5 million kilometers away, more comparable to WASP-12b's scorching proximity. Orbital period. Roughly every 111 days, it swings inward violently, making a dramatic pass near its star. Drastic temperature swings. Thermal shock. This planet's yearly cycle sees it shift from 526 degrees, 979 degrees, up to around 1026 degrees, 2239 degrees, in as little as 6 hours during its close approach. That's a faster temperature change than anything we observe in our solar system. Storms beyond imagination. As the planet nears its star, the atmosphere experiences a sudden enormous injection of heat, likely generating terrifying storms with wind speeds exceeding 700 km/h. Then, after just a brief cosmic moment, HD 80606b slingshots back into the outer part of its orbit, cooling back down. HD 189733b, raining molten glass distance and appearance 63 light-years away. This planet is easier to observe than some others due to its orbit and the brightness of its parent star. Vivid blue atmosphere. Silicate particles in the atmosphere scatter blue light, giving it a mesmerizing azure color reminiscent of Earth, at least when viewed from afar. Terror in the clouds. Temperatures over 900 degrees C, 1,652 degrees, enough to vaporize many metals. Supersonic winds, measured or estimated at up to 8,690 km/h, 5,400 mph, about 7 times the speed of sound, Mach 7+. Such wind speeds would tear apart most structures. Glass rain, silicate droplets. The intense heat and presence of silicon-based compounds in the atmosphere likely condense into molten glass. Combine that with horizontal wind speeds faster than Earth-based missiles, and you have shards of molten material scouring the planet at lethal velocities. It's the quintessential perfect storm of cosmic horror. Our familiar giant, Jupiter's Great Red Spot. Not an exoplanet, but, within our solar system, Jupiter resides about 5 times farther from the Sun than Earth does, orbiting at an average distance of 778 million kilometers, 484 million miles. A solar system. Nightmare. Although Jupiter is close compared to exoplanets thousands of light-years away, it's still home to the largest storm we know of within our planetary neighborhood. Why its frightening storm diameter? The Great Red Spot, GRS, is larger than Earth itself, a sprawling vortex spinning for at least the past few centuries. Recent changes. Observations show that wind speeds within the GRS are getting even faster. While once measured around 640 km/h, 400 mph, recent data suggests an uptick in velocity, leaving scientists wondering about the fluid dynamics fueling the storm's intensification. Persistence. No one knows exactly why the GRS has lasted so long. On Earth, storms typically die out when they interact with land or cooler air. Jupiter, being a gas giant, lacks a solid surface, potentially allowing storms to last for generations. Coroti 7b, planet of lava, and extreme contrasts. Key facts: distance, about 489 light-years away. Planet size, approximately 1.5 times Earth's diameter, making it a so-called super-Earth. Orbital proximity, Corot 7b orbits 60 times closer to its star than Earth does to the Sun. Dual temperatures. Daytime inferno. The star-facing side can soar to a brain-melting 2,593 degrees, 4,699 degrees Celsius, hot enough to liquefy and vaporize rock. Under these conditions, entire oceans of molten lava may form, or rock may evaporate into the atmosphere. Nighttime deep freeze. On the dark side, the temperature plunges to about 235.6 degrees, 392 degrees. This drastic range means the planet's environment is split between literal fire and ice. Potential lava oceans. Tidal locking. Much like TARES 2b and other close-in exoplanets, Coroti 7b likely shows the same hemisphere to its star perpetually. The day side might contain boiling magma seas, while the night side might be coated in freezing darkness. Atmospheric composition. Any atmosphere would be very thin or composed of vaporized metals and silicates, offering almost no protection from star radiation. TRAPPIST 1b, the fiery world with blood moons system overview. Distance, roughly 40 light-years away, in the constellation Aquarius I. 7 Earth-sized planets, the TRAPPIST. One star system made headlines because 3 of its planets lie within the habitable zone, sparking debates about the possibility of liquid water and maybe even life. Why TRAPPIST 1b is a nightmare extreme heat. TRAPPIST 1b, the innermost planet, roasts at around 1,220 degrees, 2,028 degrees. This is well above the point where liquid water could exist. Instead, any water is likely to sublimate into vapor. Celestial spectacle, TRAPPIST. 1b might look up at its sister planets, 6 others in the same system. Observations suggest that from the surface of TRAPPIST 1b, at least a few of these neighbors would appear in the sky like large red moons, possibly with a ruddy glow due to the star's cooler, redder light. For a hypothetical onlooker, the sight might be beautiful, but also eerie. Prospect of alien life. Other TRAPPIST worlds. Some of the other planets in the system, especially TRAPPIST 1e, F, and G, sit in or near the habitable zone. They may harbor oceans of water or supportive atmospheres. Meanwhile, on TRAPPIST 1b, any search for life would be futile given the scorching temperatures.